Hello students, how are you all? Welcome to the physics online classes, and today we will be discussing the topic AC generator, that is alternating current generator. What do you mean by alternating current? It is alternating its direction. If once it is going in this direction, then it will go in this direction. Once it is going in this direction, then it will alternate its direction downwards. In short, we can say if once it is going in positive direction and then it will go to negative direction. Simply it is alternating its direction. That's why it is known as alternating current. We will be having whole chapter based on alternating current. That is our next chapter. Okay. So alternating current generator. What do you mean by generator? Generator is something that generates it. Okay. So alternating current is a device which generates the current or which generates alternate current. Okay. So initially we shall start with the principle. What is the principle of AC generator? Principle is nothing but electromagnetic induction. Whenever there is change in flux, there will be electromagnetic EMF induced. If there is change in flux, there will be electromagnetic EMF induced. And if there is induced EMF, there will be induced current. Okay. So this is the basic principle. That is one part. And second part of the principle is it converts mechanical energy to electrical energy. It converts mechanical energy to electrical energy. And this electrical energy is obtained in the form of alternating current. Okay. Here I have written what is alternating current. That we have already discussed. That is current which changes its direction. Okay. So we shall start with construction. But before that, let me just explain you in short what happens in the in this AC generator. Suppose there are two magnets. There will be magnetic field between them. Okay. So in between, if I keep a coil. And if I rotate the coil, what will happen? There will be EMF induced because of change of flux. Okay, suppose this is the magnetic field lines. These are the magnetic field lines. Due to these two magnets, there will be magnetic field lines. Okay, if this is a coil and if I rotate this coil, what happens? Initially, all four magnetic field lines are going through the coil. As and when it rotates, what happens? The number of field lines. Now, what happens when it is turned at angle theta? The only two magnetic field lines are going through it. And as and when it rotates, there are no magnetic fields passing through that coil. So which means that whenever the coil is being rotated, the flux that is going inside is being changed. Okay. So based on this change in flux, there will be induced EMF, and due to that there will be induced current. Okay. So this is the basic phenomena. So let us start the construction. So initially what we want? We want two permanent magnets, say North Pole and South Pole. Due to this, there will be magnetic field between them. Okay, there will be magnetic field between them. Now we need to keep a coil in the between. Let us say this is our coil. Okay, this is our coil, or you can say armature coil. Okay, this is known as armature coil. I'll write down the name. Armature coil. This is just turns coil, normal coil. Okay. At the end of the coils, there are slip rings. Let us name it S1 and S2. You can name it anyone. There is no necessity. S1 and S2 are slip rings. Just write the name. I'll explain you what is S1 and what are the slip rings. Okay. From slip rings, it is connected to a brush. Let us say B1, B2 over here and B1 over here. Okay, it is connected to brush, and this is then connected to the load. You can say it may be connected to the bulb also. It may be connected to any resistor or anything wherever the current is required. Okay, so that is connected to the load. Okay. On top of that, there will be an axle which will be used to rotate this axle. Okay, axle क्यों होती है? To rotate the coil, because here it is said that it converts mechanical energy to electrical energy. So we need to give some mechanical energy to it, which means we need to rotate by some means. So to rotate, to hold that, we need some axle. Okay, and this is rotated in this direction by uniform angular velocity omega. Okay. I hope this much is clear. Now we'll come back to S1 and S2. What are the slip rings? What happens अगर ये coil घूमती रहेगी, if this coil keeps on rotating, what will happen? These wires will get interconnected. एक दूसरे में उलझ जाएंगे. They will get interconnected. So in order to avoid this, what it is like? Suppose this is the slip ring. This is the slip ring, and the wire that is coming is connected to the slip rings in this manner. Okay. So what will happen? If the rotation will take place, this wire will only rotate on this. It will only rotate on this, which means that slip ring will remain stable and the moving coil wire will only rotate on this. This wire will rotate on this. This wire will rotate on this. So what will happen? There is no possibility of getting interconnected. Okay. So for that, two slip rings are used. S1 and S2 slip rings. Okay. Slip rings. Okay. Then it is connected to brushes. Why brushes are used? Just to connect the wire through the slip rings. As you need to take the charge from the slip rings, it is connected to a brush, which is just a carrier, or you can say an intermediate link between the slip rings and the load. Okay. The wire that is going to the load and the slip ring, it is just an intermediate mode to carry the charges. Okay. So B1 and B2 are brushes. Okay. So I hope that construction of this is very clear to you. Now in this, from here at this point, the coil is being rotated with angular velocity omega. As and when this rotates, this will cut the magnetic field lines. Okay, so there will be change in flux, and when there is change in flux, according to Faraday's law, there will be induced EMF inside it. Okay, so you can just very fast copy this diagram. Okay, take a time, very fast do it. Okay, you can pause it. Okay, just pause करके draw कर लेना. Okay, now we'll be going towards the working of this. Now what do we have working? Initial condition. In initial condition, the coil is in normal position. Suppose, say, it is in this position. Okay. It is in normal position. Let me explain by this. Okay. अगर ऐसा है, it is remaining in normal condition, that is at 90 degree to this magnet, or you can say perpendicular to the magnet. So what will happen? The area vector will be in this direction. Area vector will be in this direction. Area vector is always perpendicular. ऐसे कोई plate है, okay? If it is in this manner or in this manner, it doesn't make difference. Area vector will be in this direction, and the magnets are in this position. So area vector and the magnetic field will be in same direction. So suppose, let us say it is at time t0. Okay, that is initial condition. This is the thing. Okay, so what will be flux phi at that point of time? Phi will be equals to B into A, B dot A, that will be equals to BA cos theta. What is theta over here? Theta is angle between B and A. In initial condition, we know that the direction of magnetic field is also same and the area vector is also same. So what happens? Theta is equals to 0 at this condition. Okay, in this condition theta will be equal to 0, so flux will be B into A at initial condition. Okay, this is our initial condition. Now what we'll do? We'll just rotate this coil by some angle theta. We'll rotate this coil by some angle theta with uniform velocity omega. Okay, so what will be our condition? Let me draw it over here. So if I rotate it with some velocity and some angle theta, the angle with the area vector will make the angle with which I am rotating it with the magnetic field. Okay, So this will be theta if this is the area vector. Area vector will make some angle theta with the magnetic field lines. So if I say at time equals to t, I have rotated with angle theta equals to theta, with some angle theta, angle equals to theta. Okay. So at that time what will be flux? Flux in each coil will be equal to B into A, B dot A. So I can write B